Hello everyone, welcome back. So let's look at various other places where we're going to be using work, calculating work. So in this case, it's the work of a weight. Now this is the work done by the gravitational force which is acting on a particle. Now weight points straight down, so the only change that we care about is the change in the y direction, if y is, up and down. So what would our work be? Well, it's simply force times distance, just like last time. Force times distance. Now, since our origin is usually on the ground, and therefore any displacement would be positive if it's going up, well, work is always going in the negative direction, so this is always a negative thing. However, if we're going from high up down, then it would be giving us energy. It would be doing a positive work. Now weight is constant, and therefore we can pull it out of this equation very simply. You get a nice little equation that says that the amount of work done by a weight is equal to the weight times your change in position in the y direction. How about a spring force? Well, spring force is going to surprise you. Now the equation for the force is simple. It's the stiffness of the spring times its displacement from its unstretched position. And then if we want to do this, we have to integrate, because that force is a function of position. And so when we plug in this equation, we get that the equation for the spring energy is ks squared. So 1/2 ks squared from where it was minus 1/2 k squared from where it began. Where it goes to from where it began. Now, what you need to realize is that if the particle is attached to the spring, the force F exerted on the particle is always opposite to that exerted on the spring. Thus, the work done on the particle by the spring force will be negative. Always negative. Because it will run into that, and that will be resisting the direction it's going. So don't forget that negative sign. That is important. A few other things to think about spring forces. All those equations only for linear springs. Maybe, just maybe, I'll throw a nonlinear spring at you. That would not be fun. And you would have to reintegrate those equations. Second, the work of a spring is not just spring force times distance, because the spring force changes with position. This is something that happens to most students. They make this mistake at some point. So don't let that be you. And finally, third, always double check the sign of the spring work after calculating it. It is positive work if the force on the object by the spring and the movement are in the same direction. So I mean, if you have a ball and it's attached to the spring and it's going to try to move suddenly in either direction, it's going to be negative. However, in a second situation, it might be that you have the spring, the ball has run into it, and now the ball is being accelerated backwards. That's a case where it could be positive. It's just in most cases it's going to be negative, so be very careful about that. Okay, so we will stop there for today. Thank you for listening, and I'll see you all next time.